Let's define the following function f of x by the natural log of x plus the square root of x squared plus 1. So in our case, we want to prove that f of minus x is minus f of x. This means that we want to show that f is an odd function. Okay, but before that, we want to find the domain of this function. What are the values of x that would make this one defined? That means finding the values such that x plus square root of x squared plus 1 is bigger than 0. But we can note one thing here is that since we have this square root of x plus 1, so the issue that we can have is that given any, or we can do it this way. So we know that x squared plus 1 is bigger than the absolute value of x. So once we add x to both sides, we will get the absolute value of x plus x. Okay? So when x is positive, we have x squared plus 1 plus x is bigger than 2x, is bigger than 0. Okay? So we don't want this one to be 0. When x is 0, we have no problem for this one, because if x is 0, we're going to have the natural log of 1. So assuming that x is bigger than 0, we have this one, x squared plus 1 plus x is bigger than 0. If x is positive. If x is negative, so we have the square root of x squared plus 1 plus x is bigger than the absolute value of x, in this case is minus x, plus x, which is 0. That means for all the cases, we have x plus x squared plus 1 is bigger than 0. So that means our domain for this function is defined on the whole set of real. So the domain is this one. Okay, now we want to prove that f of minus x is minus f of x. So let's plug my f of minus x. So we have ln of the minus x plus the square root of minus x squared plus 1. So this would give us minus x plus x squared plus 1. Okay. Now to get our result here, we multiply by the conjugate. So we're gonna multiply by minus x plus square root of x plus 1 by x plus square root of x plus 1 over x plus the square root of x plus 1. Okay, once we do that, on the top we have x, we have the square root of x plus 1 squared minus x squared. And since this one is always positive, we have x squared plus 1 minus x squared, which is 1. So on the top, we have ln of 1 over x plus the square root of x plus 1. Okay? And now using the fact that the natural log of a over b is ln of a minus ln of b. So this gives us ln of 1 minus ln of x plus the square root of x squared plus 1. And we know this is 0, and therefore we get minus ln of x plus x squared plus 1 square root. And this gives us that this is just minus f of x. Okay? This shows the result that we want to do. So this proves that the f of minus x, which is this one, is equal to minus f of x. And that means our function is odd. So the problem was with this domain of definition, but we had to get rid of it using this technique. Okay? And that's what we need to prove.